Hi guys, it's Miss Mouton-Pentz. So we need to go over your stats questions from your review in case any of you have any questions regarding that. So the stats questions started at 27 and they went through 35. So bear with me. We'll get through these as much as we can, and hopefully any questions that you have will be answered during this time. Okay. All right, so for this first one, the following data was collected based on the average amount of hours students in Barnett's class sleeps each night. So whenever we look at that, so we got box plots. So box plots deal with medians. So that means I need to find the median. So I need to know how many pieces of data I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I think about it, 13 means I'm going to have 6 on the left, 6 on the right, and then there will be the one that's in the middle. So 1, 2, 3, 4, 5, 6. This right here is the number in the middle, which is my median. And then, so if I look, I had 6 on the left. So then that means that between the third and the fourth number is going to be my lower quartile. So in this case, in the middle of 5 and 5 is 5. And so then my minimum number is 4. And then I go up here to get my upper quartile. So that's going to be between 8 and 9, which is going to be 8.5. So I'm just going to kind of write that right there. And I'm going to write this is 5, and then this is 4, and then 6, and then 10. So these are my 5 numbers that need to be plotted on my number line in order to show that. So if we look here, this one starts at 4, and then it's 5. Maybe that one's 6. 8.5. This one stops at 9 though, and I need it to stop at 10. So therefore, that one is a big fat no. All right, so now whenever we look at these two, if we notice, these look exactly the same. So if one of them is it, then the other one is it, which would mean there was a mistake on this paper somewhere to have 2 correct answers on a multiple choice question, but let's check and see. So this is 4, this one is 5, this one is about 6. One looks, here's 8, so about 8.5, close to 9. And then this one is 10. So it looks like for this one, if I were to have been the one giving you this question, then you could have answered B or C, because that would have been the correct answer. If you look at this one, the lower quartile they have is greater than 5, so that automatically takes that one out. Okay, so for this one, B or C would be the right answer. Go on the next question that we have. So we have a histogram. All right, we'll try this again. I don't know what happened with the thing all of a sudden not picking the paper back up, and you just got to see the top part of this black desktop. However, okay, so what we were talking about is on number 28, this is a histogram. So if you remember, we talked about this. So this histogram starts at 44. So remember, the first part of the bar tells you where that bar starts. So whenever you look at this second number right here being 53, that means 53 is part of the second bar. It's not part of the first bar. So that first bar is goes up through 52.999999. So that's how we actually read our histograms. So for the first question, it says 2 people scored between 89 and 97, and we are looking for the statement that is not true. So between 89 and 97, so that's going to be our last bar on our histogram. And if you look above it, that's 2. So that one is actually true, which means it's not the answer to our question. because our question wants to know the one that is not true. So then 6 people between 62 and 70. So that's going to be this bar right here. And the number at the top of that bar is 6. So that also is a true statement. And then 3 people between 44 and 52. So that's going to be our first bar in our graph. And therefore that one is 3. So that is a true statement. So then between 53 and 61, well, the number above that bar is 1, and this says 3. So therefore, that makes that the answer that is not true for that histogram. All right, so for number 29, so this one says, Josie is looking at her data display, and she knows that 75% of her neighbors paid less than $250,000 for their house. So what type of data display would show this most clearly? Well, let's think back. So histograms show things over intervals. Still kind of a little hard to pick out where 75% is. But if you think about when we make our box plots divide our data into fourths, which are 25%. So 75% is a multiple of 25%. So therefore, a box plot is going to give us that most accurate data of her being able to draw that conclusion. All right, so for this one's talking about, this calls it a line plot, but it's also called a dot plot, which is what we called it in class. They mean exactly the same thing. So now we have the number of inches each student's height increased 1 year for 2 different groups of students. So which of the following statements is true for the height increases shown in the line plots? So the 2 things, if you look down here, that they're talking about is the median and the mode for every single one. So median, mode, median, mode. So therefore, if we look at this one, and you can either kind of count off to find the median, we can easily see that our mode on this group 1 is 4. And then on this one, the mode is 5. So whenever we go down here, the mode is greater for group 1 than group 2. That's not true. So that one's automatically out. Greater for group 2 than for group 1. Part of that is true, so that's a possibility. The mode is greater for group 2. That's a possibility. So we're now down to between B and C for this particular problem. So now I need to figure out the median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. So that means that I should have 7 numbers on the left of my median and 7 numbers on the right, and then the median. So 1, 2, 3, 4, 5, 6, 7. So therefore, this one, the median is also 4. So the median and the mode are 4. And then when we look here, 1, 2, 3, 4, 5, 6, 7. So on this one, the median is 3. So median and mode are both greater for group 2. Well, this one, the median is less. So therefore, our answer for that one would be C. Okay, so now for this one. So these are what we actually call frequency tables. And in frequency tables is where you put your tally marks. So whenever you look at this, there are 2 groups, each consisting of 38 high school students participated in a survey about the number of times they sent a text message during lunch. So the frequency tables show this. So whenever you look at it, the number of people that sent 3 texts was 3, and then it goes up to 10, and then basically 14 people sent 10 text messages. So then when we go over here, 2 people sent 2, but then 20 people sent 12. So whenever we look at this, so when we talk about the best measure of center, remember we have 2 possible measures of center. They are either the median or the mean, one of those two. So whenever you look at this, you can kind of tell that these numbers of text messages, the number of students sending text messages gets bigger. So therefore, if there's more in this bottom line, and then it kind of makes a trend of going upwards almost, well, the same thing is happening over here. So neither one of these are going to be symmetrical, or what we would call a normal distribution, which is when we would use mean. So therefore, the best measure of center, because our data is skewed, then we would want to use the median. So whenever it talks about to justify, it's going to be because both of these have skewed data. They are skewed data. So therefore, that's why we would use the median. All right, so the next one, question number 32. So they asked some people the number of pairs of jeans owned by 18 randomly chosen students from 2 different high school classes. So whenever you look at this, we got class A. So the people who are talking about the number of pairs of jeans that they own. So 2 people own 1 pair. They must live in Florida because we don't need jeans very often. And then you have 2 students own 8 pair. So they must like jeans. And then whenever you go down here, we have 2 students who own 1 pair. And then we have 1 student who owns 6 pair. So whenever you look at this, if you look at the shape of this one almost looks closely symmetrical until you come out here with these 2 people that had 8 pairs of jeans. So therefore, this one makes our data skewed to the right. So therefore, anytime that you have data that is skewed, the measure of center that you're going to use is the median. So median, because class A data is skewed right. And it really doesn't even matter about, at this point, class B, because both of them would need to be symmetrical in order for us to use the mean. So therefore, we would use median for this particular data. All right, so for question number 33, so this is our state trooper who is using his radar gun. So I went ahead and front loaded this just a little bit. So there were 19 cars going northbound, and there were 20 cars going southbound. So I went ahead and listed them out like this rather than in this table. So now whenever we go, it says to draw actual box plots of this. So whenever we go to do that, so if there's 19 pieces of data in here, well, that would simply mean that there would be 9 pieces of data to the left, 9 pieces of data to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So then this number right here is our median for the northbound. And then, so if we're going to create a box plot, so we're going to use 60. So then if we look, we talked about that we would have 9 over here. So that means 1, 2, 3, 4 to the left. So then this is going to be, because that gives us 4 to the right also. So this is going to be our lower quartile. And then we do the same thing, 4. And then our upper quartile. And then 4 is to the right also. So that gives us our, and then this is our maximum. So this gives us our 5 points for our box plot. So now this one though has 20. So whenever I go to find the number in the middle for this one, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now my median is actually in between these two. So therefore my median is 63.5. So now there's 10 pieces to the left. So then that means I have 5 to the left. So that means in between these two would be where my lower quartile is. So that's 59. And then I would do the same thing. So I go 5 more. So then that gives me 67.5. And then I have my maximum and I have my minimum. So then those are my data points that I'm going to use to create my box plot. So whenever I go to make that, I'm going to create them both using only one number line. So therefore, my smallest number on here is 55 and my highest number is 83. So that's where I'm going to go in here. So if I label that 55, 56, 57, 58, 59, so 60. Okay, so here we have the number line. So we're going to plot our 5 points on here. So I'm going to do northbound first. So northbound has 60, 63, 65, 66. And then I look and I'm like, oh, 83. That's all the way here. So if we look at how far this is, I'm guessing that 83 is an outlier. So if you remember, how we actually find the outlier is we find our interquartile range. So for our northbound, our interquartile range is going to be 66 minus 63, which is 3. So our IQR is 3. So then we take our IQR and multiply it by 1.5. So that's 4.5. So something on here is going to be an upper outlier if above my quartile 3, which is 66, if above that number is 4.5 more than that, so that would put me at 70.5. So if I have any numbers higher than 70.5, then they're an outlier. So therefore, 83 is an outlier. So therefore, we kind of show that either with a separate dot or an asterisk. So then that means that I'm going to go and put 70 as my maximum and then just count that as an outlier. So then I actually draw my box at this point using these data points. All right, so this is northbound traffic. So then for southbound traffic, I've got 55, 59, and then 63.5, and then 67.5, and then 71. Okay, so these are our two data distributions through a box plot. So this one right here, I'm just going to label it northbound, and I'm going to label this one southbound. So northbound only had 19 pieces of data. So if I had to guess, the 19th person that came by was 83 miles an hour, and the state trooper decided he was going after that person. So therefore, he didn't clock his 20th person because he got in his car and pulled this person over and gave them a ticket. That's what happens when you're an outlier going down the highway. When you're on the upper end or even the lower end, sometimes they might stop you for going too slow also. So whenever you look at this, so over this time period that they were actually talking about, let's talk about some of the things that are actually different. And I'm not going to write all of this down. Let's just kind of look at it. So if you look at the southbound, this right here is a pretty even. Looks like our whiskers on the end look about the same length. It looks like our median almost is in the middle of our quartile 1 and our quartile 3. So this right here looks like very evenly distributed. So, but whenever you go down here to your northbound, this one, it's not too bad. You know, our median is a little bit, you know, to the right in between our quartiles, but this outlier is what does a lot of, makes things a lot different for the northbound because of that. So if the state trooper were going to like use this data to go and make some claim to, you know, whoever he's gathering this data for, he really should use the median to accurately portray the data, because once he has this outlier out here, that's really going to affect the mean of the northbound traffic. So he would want to use the median. So if we look at the IQR, so the IQR is our middle 50%. So if you look at this IQR is a lot greater than the IQR in the northbound traffic. So that's another difference that we can actually talk about. If you weren't talking about this outlier, then there would be a much less spread of northbound traffic. But the fact that the outlier is there makes the spread much greater. Trying to think if there's anything else that we want to say about that. So just remember, this right here says basically that 25% of the cars were traveling at a speed between 58 and 59 miles an hour. And then 25% of the cars were traveling between 59 and 63.5 miles an hour. And so all of this is kind of broken down into 25%. Okay? All right. All right, so whenever we look at this, so this one's talking about some haircuts. So we got female and we got male college students. So whenever you look, it says, it asks them what was the last cost of their haircut. So whenever you think about that, the minimum for both of them was 0. So I don't know if that person says, they haven't had a haircut and that's why it's 0, or they cut their own hair so it didn't cost them anything. I'm not really sure. However, they let their friend cut it. I don't know. I guess there's lots of possibilities in there as to why that cost would be 0. But the first thing it asks us to do is to use our data to sketch 2 side-by-side box plots. So the first thing we need, so for females, we go from 0 to 150. And then for males, we go from 0 to 35. So whenever I go to graph that, I'm going to let this be 0. And again, I'm going to use the same number line. So there's 50. There's 100. And there's 150. Okay, and the nice thing about this one is they actually give us all the points that we need to plot anyway. So for females, their lowest was 0. Their highest was 150. And then their first quartile was 20. Their median was 31. And then they went to 75. Okay, so then whenever we draw this, all right, so then for the guys, we go 0, and then the maximum was 35. So there, and then we have 9.25. So that's going to put us about right there. And then 17. And then 20. So here's male, and then here's female. So, part B says, how would you describe the difference in haircut costs between males and females? So whenever you look at this, well, obviously, when it says shape, center, and spread, so the measure of center is the median. So the median is lower for males. You know, $14 lower, not a huge difference. But whenever you look at the spread for females is so much greater than that of males. And then the shape, the males is much more symmetrical in shape than the females. That's probably what I would say about that. So then in question number C, it's question letter C, it says, why is the mean greater than the median for both of them? Well, whenever you look, and it tells us up here in the chart what the actual mean is for both of them. So whenever you look, 50% of the people, so if you notice our median, the line going through our inner quartile range, our quartile 3 and quartile 1, is closer to quartile 3. And then this whisker out here is a little bit longer than this whisker. So that means that 50% of our data is here. So because 50% of our data seems to be a little more shifted to the right, that's what's going to make our mean higher than the median. You know, our median is 17 and our mean is 20. So it's not, you know, that far off for that. But then whenever you go and look at our females, our female median is 31, but then the mean is 52. Well, if you look, here's 50% of our data in here. Well, then the other 50% is here. So 50% is this wide. So 25% of the people spent between $31 and $75. And then another 25% of the people spent between $75 and $150. Well, that's a lot. So that's what makes this mean go up. So then for D, which one would be more appropriate for describing the centers? You definitely want to use the median, because this data right here is definitely skewed because of this long part right here. So because of that skewedness, I don't even know if that's a word, we definitely would want to use the median. All right. Okay. So our last problem on statistics, we're going to talk about, and we're going to compare the ages for people in Kenya based on a census, and then the ages of people in the United States based on a census. So the first question asks, what measure of center and spread would you use for the Kenyan graph? Well, just look at the shape of the Kenyan graph. So that shape doesn't look very symmetrical or uniform. So therefore, which means it doesn't have the shape of a normal distribution. So for that reason, the measure of center that we're going to use is median. And so therefore, if we use median, then our spread is going to be IQR. Those two things go together. So then for the second question, what measure of center would you use for the US graph? So if you look here, it looks like we're here, and then all of a sudden we drop off a lot. So because this drop off right here, we also would use the median. And then because we're using the median, it would be the IQR. Okay. So whenever it says to describe the center, so we just said we would use the median. So whenever you look over here, these are all percents. So they probably should add up to 100%. So basically my median is going to be pretty much where we're kind of at the 50% mark. So this right here is about 17%. This one's a little over 14%. So then this one's about 11%. So basically what happens is the 50th percent is going to kind of come in this column right here. So whenever we look at that, so for this one, there we go. Our median for Kenya is somewhere between 15 and 20 years old. So then when we look at our spread, so our spread basically goes from 0 to about 90. So our spread is from 0 to 90. And then the shape of the Kenyan graph is very much skewed to the right. All right, so then whenever we go over here to the United States graph, whenever we look at that and we start adding up to where our 50% of our people would be, so this right here is about 6.5%. A lot of these are about 6.5%, kind of go up to 7 on some of them. But whenever you, somewhere in here is about where our 50% would be. So therefore, for the US, our median, which is our measure of center, is somewhere between 35 and 40 years old. That's a big difference if you think about it. So 50% of the people in Kenya are kind of less than 15 years old, and in the United States, 50% are below 35 years old. So that's actually a pretty big difference of that. So then whenever we look at the spread, our spread is very close to the same. Our spread here goes from 0 to 100 in the United States. So they both have a very wide spread. And then the shape, so it almost looks like this is a uniform distribution up until we get to about 55. So after a 55, then it starts really tailing off. So then it becomes again skewed to the right. So then how are they different and how are they similar? Well, they're different in terms of their medians are very different. Their shape is different in the fact that, you know, we're pretty uniform over here in the first part, but then they are also alike in the fact that they're both skewed to the right. And they also are very similar in the fact of their spread. So, you know, the age range of people in both of those countries, in the United States and Kenya, is very similar. It's just the percentages in each of those categories is very different. Okay. All right. So we have officially wrapped up statistics, and I hope that this answered or cleared up any questions that you may have had. And I guess if I don't teach you and you're watching this another algebra teacher, then you may not hear a video from me again. But if you're mine, I hope, and regardless if you're mine or not, I hope everybody has a great day and good luck on your quarter 2 exam. You guys have got this, okay? Thank you. Bye-bye.